Now that I've connected the sensor to the robot, I want to be able to read the sensor, store the value of the sensor in a variable, and then expose that variable to the web, much like how we exposed functions to the web. And we'll use Particle Explorer to look at that exposed variable later. But first, I need a little bit of firmware to do the reading of the sensor. If we go back to the CodeTak robotics library, there's actually another example there that says to_sensors.ino, and that's an example of how to read data from the thermopile sensor. We will hit the Use This Example button, and it will create a new project with this code, and I still have access to my old project 1_robot if I wanted to look at that for any additional information, but now I have this to_sensors code. So you'll notice first that this firmware is actually scaled down quite a bit, and it doesn't control any of the motors on the robot. It only reads the sensor. The first thing is you'll notice a new section called variables, and I'm going to have two variables inside of it. The first variable that I want to point out is not the first one in sequence, but it's this one that says double temperature is equal to 0. And that's where I'm going to store the data from the sensor. The sensor is going to return temperature data, and I'm going to call that variable temperature for convenience. I'm going to assume that the first value that it's going to have is 0, and that's basically means that when I boot up the robot, it's going to assign the value 0 to the variable temperature before any data has been read. And that's a good idea in C++ to assign a value to every variable when you create it. And the type of data that it's going to store is double, and that means double precision decimal. So simply put, you want to say double temperature is equal to 0, and that creates a variable that stores decimal values called temperature, and that has an initial value of 0. Now, this one over here is the one that's a little more complex. And this is a variable that represents a connection to the thermopile sensor, and it's a type of variable called an object. So where it says Adafruit_TMP007, there's a pre-written library that's been included inside of this CodeTak robotics library. And the Adafruit_TMP007 is the type of sensor that I have. The name of the sensor, I'm just going to go ahead and call it thermopile. And notice the value that I'm giving it. This is a little weird, but when you have the name of this complex type of variable called a class, and a parentheses right here, it runs what's called a class initializer or a constructor. So going down to the setup, this particular class, Adafruit_TMP007, requires that you call something called the begin function. And what that does is it establishes a connection to the thermopile sensor, boots it up using that I2C protocol, the SDA and SCL pins, and tells the thermopile sensor to begin operating. But simply put, I need to tell that thermopile sensor to begin. Not every sensor requires a begin function. For example, the ultrasonic sensor library that we have included with this super library of CodeTak robotics doesn't require a call to begin. Now that I've done that, I'm going to expose the temperature variable to the web using particle.variable, which looks a lot like particle function. Inside of the loop, this is where I actually need to get the thermopile sensor to read. Remember that loop runs continuously. So what I'm doing is I'm taking that temperature variable and I'm giving it a new value. That new value is going to be through this function called thermopile.readObjTempC, which basically says go to my thermopile sensor, which I called thermopile, and activate on it a function called readObjTempC, which retrieves the temperature from the thermopile sensor. That value, once it's been retrieved, will store itself inside of temperature. And then notice that my loop says delay 1000. And the reason why is because I don't need to continuously read the thermopile sensor's value. I'm only going to read it once every second. Typically, it's a good idea to put sensor readings inside of a loop so that it can continuously update, but I also add a delay so that it's not just continuously trying to update that sensor value. So once that's done, I can flash the firmware. After it flashes, I'm going to go ahead and look at Particle.io Explorer. Once the device comes online, I'm going to refresh this page. I'm going to sign in. You'll notice that it says one variable is found, and there's a little refresh button right here. If I hit it, it will receive a value from, it will read that temperature variable and receive that value from the thermopile sensor. Now, I have to manually refresh it. It's not on some type of loop that automatically refreshes on the web, although it does refresh in real time on board the device. So let's say I was to put my finger over the sensor itself. That should mean that the temperature should rise. So I've got my left hand's finger over the temperature sensor, and I'm going to hit the refresh button, and it kind of went a little bit crazy, but that's okay. Maybe I shouldn't be touching it directly. Let's try this. So I have my hand above it, and sensors behave a little differently depending on different things. Like for example, right now you'll see that every single time I'm refreshing it, what you don't see off camera is that I'm actually moving my hand away from the temperature sensor itself until I take it away completely. And it reads that the average room temperature is going to be 24 degrees depending on what it's pointed at. And that's basically how you access a sensor and read the values of the sensor using Particle.io Explorer.